All right, welcome back. Now what we're going to do is we're going to use this example here, and we're going to solve to see what the x-intercepts are and what the y-intercepts are. Now there may be one, there may be more than one, there may be none. Okay, so let's do the x-intercept. Okay, so the x-intercept, we're going to set what? Y equal to 0. Okay, so if we set y equal to 0, we get 0 equals the absolute value of x minus 1. And so if we solve for the absolute value of x, we get the absolute value of x is equal to 1. And that means, based on the definition of absolute value, that means that x could either be 1 or negative 1, right? So that means that x is either equal to 1 or negative 1. And so that means we have two y-intercepts. We have what? 1 comma 0, and we have negative 1 comma 0. So in this case we have two x-intercepts. Okay? Now what about the y-intercept? Now what we're going to do is for the y-intercept, we're going to set x equal to 0. And when we do that, we get y equals the absolute value of 0 minus 1, which gives us negative 1. And so in this case here, we only end up with one y-intercept, and that's going to be at 0 comma negative 1. Okay. All right. And then just to reiterate, there are going to be cases where you may not have one of the two intercepts, right? For example, if I have a circle out here, right? This graph of this circle does not intersect the x or the y coordinate. So in this case, there would not be any intercepts. If I have something like this, if I have a parabola that opens upward, in this case here, we would have one x-intercept, but we would have we would have one y-intercept, but no x-intercepts. Okay? So again, these would be examples where if we did try to solve the equation, we would get an imaginary result. Okay? And so anytime you get an imaginary solution when you're trying to solve for either the x or y-intercept, that tells you that there is none.